So in this last video, I want to look at a problem that's very similar to the last problem on your homework. And in fact, I just took this one off of the homework, and it changes the numbers, so yours won't be exactly like this, unless you get lucky, I guess, if it randomly generates numbers that are similar to this. So I thought this was a neat problem. It really makes you think, but also it kind of gets your mind thinking and gives you some techniques for solving problems in kind of a way that maybe you're not normally used to. And that way is by setting up several relationships or several equations in order to solve. And so, in other words, you're going to solve a system of equations. And so, basically, what this wants you to do is it wants you to find this is like a cubic polynomial, and it wants you to find A, B, C, and D so that the polynomial has a local maximum at 0, 0 and a local minimum at 1, negative 11. Okay, so now it doesn't want you to randomly guess values here, and hope that you get your local max and minimum. Okay, what it wants you to do is it wants you to use this information here. This is giving you information, and use that to set up a system of equations that you can then solve for these. Okay. And so what information is this giving you? Well, first of all, it wants this thing to have a local maximum at 0, 0. So at the very least, right, f of 0 has to equal 0 in order for it to have a maximum there. And it wants it to have a local minimum of 1, negative 11. So at the very least there, f of negative 1 has to equal, f of 1 has to equal negative 11, right? So these two conditions has to hold. This isn't going to give us enough information though, but notice if this is a maximum and this is a minimum, what it means is at these 2 points the derivative is going to have to be 0, because this is a polynomial, and for it to have a local minimum maximum, they have to be critical points. So what that means is the derivative at 0 has to equal 0, and the derivative at 1 also has to equal 0. So now we're going to be able to set up what we need to find these. So let me show you how that's done. So if I put in 0 here, it's going to have to equal 0. So what that means is put in 0 into my polynomial. This has to equal 0. Well, this is nice because they all go away, and so what I learned there is that D has to equal 0. So I already got one bit of information. So now, when I put in 1, it has to equal negative 11. Well, what does this mean? Let's put in 1. And then I don't need to worry about D because D is equal, we already know it's equal to 0. So this has to equal negative 11. Well, each of these is 1. So what I really get from this bit of information is that the sum of all 3 of these has to equal negative 11. So that's cool. Now I can't tell you what those 3 are, but I know they have to add together to be negative 11. So we're going to need some other equations. So if you have a system, if you have an equation with 3 variables, then you need 3 equations, right? Well, that's kind of handy because I know that both of these derivatives here have to equal 0. So what I'm going to do is I'm going to find the derivative of this. So f prime of x here, this would be 3a to the x squared plus 2b to to the x, and this would be plus c. Okay, so basically when I put in 0 into this, f prime of 0 has to equal 0. So I'm going to put in 0 here. And so I get kind of the situation up here that all of these go away and you're left with just c is equal to 0. So now, that's nice. So now I just have the equation a plus b is equal to negative 11. And I know c and I know d, right? So now let's plug in this last one. And so what that tells me here is that 3a times 1 squared plus 2b times 1, that also has to equal 0. Well, this is just saying 3a plus 2b has to equal 0. Okay? So I don't want to try to squeeze all this in. So basically what I have here is a system of two equations. One says a plus b and c is equal to 0. So a plus b is equal to negative 11, and then 3a plus 2b is equal to 0, right? So now I need to solve this system. So I think it'll be easy to just, I'll solve this maybe for a. So that first one. So I get 3a is equal to negative 2b, and then a is equal to negative 2b over 3. And now I can plug that one in up here. So when I do that, I get negative 2b over 3 plus b is equal to negative 11. So now I need to solve here for b. So this is really like negative 2/3 b plus b is equal to negative 11. So that helps. So what this means here is that I get, this is 3/3, so I get 1/3 b is equal to negative 11. So b is equal to negative 33. So now I got b, right? So I can plug that back in here. So a minus 33 is equal to negative 11. So a is equal to 33 plus a negative 11, or 33 minus 11, which is 22. And so now I can finish. My a has to be 22, my b has to be negative 33, my c has to be 0, and my d has to equal 0. So then my function here is really 22x cubed minus 33x squared. So that's my function. Let's actually come back here. I'm gonna write this down. So this is my function. Let's check and make sure that's the case. So I want it to have a local maximum at 0, 0, and a local minimum at 1, negative 11. So what I could do is I can take the derivative here, and when I do that I get 66x squared minus, bringing this down, 66 x. And so now, setting this equal to 0, I get 66x squared minus 66x is equal to 0. And so I can bring out 66x, and I get x minus 1. is equal to 0. So I get a critical point at 0 and a critical point at negative or at positive 1. So if I made a little table here, I would have negative infinity to 0, 0 to 1, and then 1 to infinity. This is using the first derivative test, right? And then just plug in a test point here, like plug in negative 1. So this would be negative 22 minus, so this is clearly negative. If I plug in 1/2, let me just, I'm going to plug it in here just to make sure. 22 times 0.5 cubed minus 33 times 0.5 squared, and that is negative. Oh, wait. I wanted that to be oh, so that's a maximum of 0, 0. I bet I did this wrong. So if I put in 1 here, I would get 22, or put in negative 1. I'm sorry, I'd get a negative 22 minus, oh, the mistake I made is I put it into the function and not the derivative. I got to put it in the derivative. So this would be, if I put in negative 1, I would get 66 plus 66. So this would be positive. And then when I put in 0.5 in here, so let me do this, 66 times 0.5 squared minus 66 times 0.5, and I get a negative here. And then here I can put in 2, so 66 times 2 squared minus 66 times 2, and that's a positive. So here, going from positive to negative, that makes this a max, and then going from negative to positive, that makes this a min. And so indeed it does have a local max at 0, 0 and a local min at 1, negative 11. I guess you could plug in 0 into here and you do get 0. If you put in 1, then you're going to get negative 11, I think, because this is 22 minus 33, negative 11. So there you go. So that, I thought, was an interesting problem, different than things that we've seen. It involves kind of setting up, finding all the information it gives you, the conditions, and they set up equations that allow you to solve for these missing unknowns. And usually it's going to involve a system of equations of some sort. In this case, because these dropped out, you were left with just a simple system of 2 linear equations and 2 unknowns, which was nice. But you could have a more complicated system. So I thought that was a great problem. I wanted to include it, and so you shouldn't have any problem solving that. On the next homework assignment, for the second derivative in concavity, I think there's some more that are kind of like this that I put near the end of that homework. So hopefully what I've shown you here will help you do those as well. Otherwise, on the homework, there's, you know, some involving the graphs, like given the graph of the derivative, finding the graph of the function, things like that. So I'll let you wrestle through that. I think you know what you need to do for those. You can think through that. So, and if you have any questions, let me know. Otherwise, that is what we're going to do for this homework assignment on the first derivative test. On the first derivative test, not just the first derivative.